Hello there, children. Today we are going to work on the Chapter 3 review. So, problem number 1. This is graphing problem here. Now I'm going to graph the first one in red. I notice it's x minus 2. Alright, equals y. So the first point I graph, go over and select the red, which I have already selected. So I go and click on the y-intercept there because my y-intercept is negative 2. Now I go my slope up 1 over 1. Up 1 to the right one or down to the left one. You connect these points with a line. It's very important. It's a line. This means arrows at both ends. As terribly as I draw them. Now I go for the other one in green. Now I select that one in green. I go up to the 3 here. That's my y-intercept. Now, the thing is, I could go up 6 to the right 1 unit, but that's off my graph. I can also go down 6. 1, 2, 3, 4, 5, and a 6. And over 1. That also counts. I connect with a line. Now, on these particular graphs, you're going to be asked, hey, what's the solution? Well, it's where they cross, if they cross. These do cross, so it's one solution. And where is that particular solution? Well, it's at the intersection point of both the red and the green line. Think about that for a second. Yep, you're right. It's negative 1 for the x, negative 3 for the y. Moving on. And you want to close your parentheses, because that is a coordinate there. Alright, so problem number 2, we're going to graph the one in blue here. So I go down to negative 4, plot my point. Boom. And I could go, well, let's think. I could go down 7 units to the right 4 units because my slope is negative 7/4. Or I could go up 7, 1, 2, 3, 4, 5, 6, 7. And to the left 4 units. Left being my negative direction, up being the positive, so that would work here. And I play a game of connect the dots. Sound effects optional. Now for the line in red, let's go here. And I plot the point at positive 4. My slope is 1/4, so I either go up 1 to the right 4 units, or I go down 1 to the left 4 units. Boom. Connect your dots with a line. Now, where do they intersect? They intersect where the lines cross, and that's my solution. There is one solution. And you need to find the x or y coordinates for that. Think about that for a second. That's right. It's at the x value of negative 4, the y value of 3. Let's keep on trucking, shall we? Alright, solve each system by any method. Well, the method I'm going to pick here is substitution. Why? Look at the second equation. I already have it pre-selected with a y. I mean to solve for y. So what I'm going to do is take that information and go to the top equation. And everywhere in the top equation that I see the variable y or the letter y, I am going to replace it or remove it, take it out, and replace it with the value of y that I had in the bottom equation. Now, why in the world would I do that? Well, if you think about it for a second and think logically here, look, I am able to do this because I am able to then get one equation and one variable, and that's super helpful for me. So I go ahead and do that. Now what I'm going to do here is simplify the right side down, give me right and left side down if I can. It's 14x plus 63 equals negative 7. I am going to subtract 63 from both sides, giving me negative 70 over here. And now what do I do with that particular item? What do I do from here? Well, I'm going to divide both sides by 14. I'm going to let it do that. And when I do that, I'm going to end up with x equaling negative 5. Alright, that's all well and good. I could circle like that, or I could start to write a coordinate pair over here. I need to find y. If only I had an equation that had y solved already. Oh wait, I do. The bottom one I used in the first place. So I get y equal to negative 5. Oh, what was x again? Oh, negative 5. Awesome. Minus 21. Y equals 25 minus 21. Y equals 4. There we go. Now, what's great about this is you could check these coordinates in both equations because they have to work in both of them. Alright, moving on. So moving on to the next set of problems here. Now, this one's a little trickier because of the following issue. We've got an issue with this, and that issue is as follows. That I could have either option here. I could use elimination, or I could use substitution. Well, I'm going to select to do elimination because I just feel like eliminating a variable. We'll multiply the top equation by a -3 because I really want to go after those x's. They seem quite easy. Now, do I have to go after the x's? Truth be told, no, I don't. Because I could, in fact, go after the y values there and get those done and out of my way. I am able to do that. But I really just want to keep it simple, keep it easy. That would be my best option. Probably the best bet that you all are thinking of is keep it simple. Now, if I went after the y's, I'd multiply the top equation by a 3, or a -3, and the bottom equation by a 4, -4, to make the y's both get to 24. Considering I'm not going to do that here, it seems mildly counterproductive, because this is really easy because y equals -1. Now, it's very imperative you don't drop negative signs. If you did, then what you would have to go back and do is, again, like you should do for every problem, check your answers. Common mistake is dropping a negative sign. So what do I do with this -1? I take it and put it into either equation. I'm going to do the bottom equation because, well, I feel like it. There's no real rhyme or reason to that. It's just I can. Now when I do this, I look at the problem and I'm like, okay, I get this. Whoop-de-doo. So what? Well, what I can do is check each of these answers into the problem and make sure they work. I could also write it as an XY coordinate pair or a Cartesian coordinate pair. Okay, moving onward. What I have here is I have another problem which is tailor-made for elimination. The reason why substitution isn't great for this one, unlike the last problem I could have done it for, is if you see here, I don't have any coefficients that have a 1 or a -1 in front of them, thus making it somewhat difficult. I am going to multiply the bottom equation by, again, a -3, just how that worked out. The reason I do that is because, again, I'm going after the x's. I could go after the y's, but that would be a little harder because I'd have to multiply the top equation by a 9 or a -9, and the bottom equation by a 4 or a -4, depending. And I really just want to avoid doing all that messy legwork. Doesn't mean I can't, just means I don't really want to. Now here, it's important to not drop negative signs again. Notice how the 3x when multiplied, -3x when multiplied by a -3 becomes positive. The y becomes negative, so when I add, I get -23y equals -46. Dividing by -23, I get y to be 2. Now, with y being 2, that's all well and good, but what exactly do I do with it? Well, think about that for a second. Thought about it hard enough? Yep. What do we do with it? Substitute and solve! Very good, imaginary voice in my head. We're going to put it into the bottom equation just because, well, actually, no, we did the bottom last time. We'll do the top this time. Does it really matter? No. Correct. It doesn't really matter. So when I do this, it doesn't matter where I put this stuff. I'm just going to do it like this. And I get a +8. You're going to subtract that over. You get -36. And when you do that, you get x to be 4. Now, with x being 4 and y being 2, you have some options here as I do it. Like, let's see what happened. You could write it like this, or you could write it as a coordinate pair, or if you were feeling so fancy-free, what you could end up doing here is if you're not quite sure if you did it right, go ahead, substitute these values back into the problem. So, let's take the bottom for a second. 4 times a Negative 3 is negative 12. A 2 times 9 is 18. Negative 12 plus an 18, 6. Good to go so far. Negative 9 times 4 is negative 36. 4 times 2 is 8. Negative 36 plus 8, negative 28. So this solution is good. You should always check your answers, folks. Okay, I will give you a second to read this word problem. Alright, so you can pause this video if you want to read it, but we're talking about rolls of shiny and fancy wrapping paper. You have to pick variables. You can use X or Y. I'm going to use S for shiny wrapping paper, and P for the plain wrapping paper. Again, you could use X, Y, you could use your own initials, provided your initials not as an O. So, it looks like a 0, sorry. So I need to make two equations here. Equation number 1, I'm going to look at Emily. Emily sold 8 rolls of plain wrapping paper and 14 rolls of the shiny, for a total of 336. So that's 8P plus 14S equals 336. I need to make another equation. Alright, let's look at Sumali. They sold 9 rolls of plain and 11 rolls of shiny for a total of 302. So 9 plain plus 11 of the shiny equals 302. So the question I have is, what am I going to multiply these things by, and what variable do I want to get rid of? Well, I'm going to attempt to get rid of the p's because I don't really want to deal with 14 and 11 if I can. So I'll multiply the top equation by 9 and the bottom equation by negative 8 because I really don't want to deal with subtraction. So what I end up doing here is doing some multiplication. So I get 72p multiplied on the top one by 9 plus 126s, and then do 336 times 9. You're left with equaling 3024. Multiply the bottom equation by negative 8. You get negative 72p minus 88s equals, and then you do 302 times the negative 8. Negative 2,416. Alright, let's do our addition work here. Now, there's one good thing about these particular problems. Could you get decimals? Absolutely. Wrapping paper can cost $17.50 or $20.75, whatever. So, fractions and decimals are okay, but one thing you're not allowed to really get is a negative, because you can't pay negative amount for something. That makes absolutely no sense. So I know this better not be a negative number. If I did, oops, I did something wrong. Luckily here, when I do all my math work, I get S to be 16. Now what do I do with that S being 16? You've got some options here. Which equations I put into? We'll go the bottom because the S is smaller there, the coefficient is smaller. Does it really matter? Absolutely not. So 9p plus 11 times 16 equals 302. Let's do a little math magic. 11 times 16. That's 176. Equals 302. 9p. Alright, so we do 302 minus that 176. We'll minus that over. Subtract it over if you will. Get 126. Equals 9p. Alright, let's just make sure we show you what's going on here. Now, when I do this, folks, and I do all this, I then divide by 9. And I get 14. Now, if I circle these, would I be done? No, because the problem is I'm missing the units. What are my units here? Dollars. So, you can write it back up with your key here. Shiny is $16. Plain is $14. There you go. Now, what some people will do, they'll write it out. You know, a roll of shiny paper costs $16. A roll of plain paper costs $14. It's fine. You can also put the dollar symbol down here and circle it, or box it if you like. That's also acceptable. Okay, moving on. So this next problem, I'll give you a second to read this. I'll leave it expanded a little bit so you can read it better. Sound effects optional. Alright, so we are buying grapefruit. So, with this grapefruit, it's large and small boxes of the grapefruit. So, I'm going to do S for small and L for large. Now, you could use X and Y. You can do whatever you want. The one thing I wouldn't do if I were you, and this is just me talking here, I wouldn't use L for small and S for large. Not the way I would handle it. That's way too confusing, and you're more likely to botch and stumble on the problem. So let's look here. Ooh, some information. So, Mofo sold 14 small boxes of the grapefruit and 3 large boxes of the grapefruit for a total of $138. That's a lot of fruit. So, 14S plus 3L equals 138. Then, here we go. Amanda sold 6 boxes of small grapefruit and 8 large for a total of 180. Wow, my straight lines are not straight. Alright, so we'll go 6S plus 8L equals $180. Now I need to figure out which variable I want to go after here. I look at the 14 and I look at the 6. I'm like, Look at the 3 and look at the 8. And I was like, well, I'll go after those. Why not? I went after the first letter last time. So I multiply the top equation by -8 and the bottom equation by 3. Because I'm going after the L's. Now, truth be told, I am more than capable of multiplying the top equation just by an 8 and the bottom equation by a -3 if I so feel the need to do so. Alright, so let's multiply here. So I get -112S minus 24L. And I do 138 times a -8. That's -1,104. Oh, big numbers. It's okay. It's okay. And then I do 3. I get, that's 18S plus 24L. And then do 180 times 3. And that's going to get me, well, let's see. 180 times 3. Think. Be 540. All right. And then do -1,404. You see where I'm going here, folks. I am going to attempt to add these things up. Now, what you should be really concerned with here is the fact that I do -112 plus 18, and I get -94S. That should be alarm bells. You're like, whoa, can't have negative variables. Not okay. Not okay at all. Luckily for us, the other side's -2. So when I divide by -94, that gives me S being 6. Much better. Because remember, I could have decimals here. Totally okay. But the one thing I really can't have, that I'm not allowed to have, and that it's not okay to have, is a negative. Alright, so I'm going to put this into the bottom equation, this S, because, well, frankly, it's smaller. And I'm really not trying to deal with large numbers if I can somehow find a way to matriculate and avoid them. Alright, so now do 180 minus 36. That's 8L equals 144. Divide that by 8. And I'm left with 18. You can put the dollar symbol on here if you want, or I'm just going to go, you know what there? My small box of grapefruit is $6, and my large box of grapefruit is $18. That's a lot of fruit. So now you've got problems 1 through 6 done, and you can go on to the next video and the next set of problems if you like. Go henceforth and do.